You know, I'm just watching that intro video. I don't usually pay attention to it, but I'm just watching that intro video. I need to update that video. I've made a slight change to my logo since then. It's just the Matter3d with the Canada thing in it. I really have to update that intro video. But anyways, hello and welcome. Happy Sunday evening. And welcome to Matter3d Canada here on wonderful Sunday evening, broadcasting live tonight from Calgary, Alberta. We have, looks like 16 people watching already, and let's see who's in chat already. We have Jose Ferreira, you were second. I don't know who was first because I don't see anybody before you. Whoever was first was probably like 4 days early or something. So welcome, Jose. Appreciate you being here. I know it's late for you and you can't hang out the whole stream, but I appreciate the time you are here. Delmar Franks is here, and we have Shadell3D. Stream Elements, hello Stream Elements, you be good to people tonight, especially if Nightbot comes on. Okay, so, and Friendship Lights, hello sir, hello. So, and Shane is here. Shane potatoes. Leo the Human is here. Collie05 is here. That's all I see so far. I'll say hi to you guys as you pop in. So yes, awesome. Remember to give me a thumbs up if you like what I'm doing. Give me a thumbs down if you don't care or you don't like what I'm doing. That's fine. YouTube algorithms are YouTube algorithms. So one more hour than bedtime for you. Cool. Well, yeah, I've got a few hours yet. It's 5:00 p.m. my time, as you probably know. So yeah, I was so cold today. Have you ever done, and I did this tonight, I'm going to be honest. I've got a shirt on underneath this one in case I get too warm. But it's chilly down here tonight. And have you ever, what I did is I threw this sweater and the shirt I'm wearing underneath in the dryer, and I let it run for like 10 minutes in the heat. And then I took it right out of the dryer and put it right on, and it's the best feeling in the world. And it warms you up in an instant. Oh, it's so good. Anyways, that's what I did today. Dropping sorted, dropping the dropping stream thing. I think it is sorted. Yeah, I hope so. I really hope so. I was printing today with I'll show you what I've been doing, but I printed a few things today, including the thing that just finished. The bed just cooled off, and I have not taken it off the bed yet, but I didn't have any droppage of signal between clipper on the screen. In other words, between my computer and the Pi that I noticed. I didn't stay down here and watch the whole thing, so we'll see. We will see. Yeah, Ken Gross, howdy, sir. And then who else popped in? Scott Lemke's popped in, and Golden Jaguar. Hey, welcome. Thank you for coming in. I always appreciate when you come in. Yeah, so what we've done last week, we left off with we did the pressure advance calibration. You just finished your first Voron build, 0.2 from LDO. Oh, you went from a 0.1 to a 0.2. I want to do that. I've got 0.1 kits. I don't know what's involved cost wise, but I do want to upgrade to the 0.2 when I can. I'm looking forward to that. So I don't necessarily need to do the top. I don't mind the lid thing, but I wouldn't mind doing the hot end update and a few of those other little updates on that. So I do like the fact that they've hinged the top now, and you're using extrusions for the top as opposed to that that build. But easy and cheap upgrade. Well, I'm going to have to look into that, Scott, and see. Well, yeah, I'm gonna look into it and see, because I like easy and I like cheap. So don't go there. So anyways, last time we had done the pressure advance, and we printed a second pressure advance cube. We've done the input shaping, which did come up with a little bit better results on the cube. I'm convinced that some of these little discrepancies here might be a cheaper filament. I don't know. And then we started working on the extrusion multiplier. Matter3d Canada, everything apart from the top is just printed parts. Okay. Oh, that's perfect then. That I can do. And the top is just extrusions, and extrusions aren't expensive. So Dominic, good morning, sir. How are you? Welcome. Shane says he's looking at which 2.4 to pre-order. Matter Hackers has a bunch of different hot end options. Okay, yeah. I've got my 2.4 has the Revo on it, the Voron Revo, and this Trident has the Dragon High Flow hot end on it. So we started last week. We were going to do the extrusion multiplier tests. We printed one piece at a 0.95 and it could be better. So, because really on the Ellis's tuning guide, he has like literally dozens of different settings for the extrusion multiplier. I did go ahead and open this up as it was suggested in a super slicer. Did I keep that open? I'm pretty sure I still have that open here somewhere. Or did that window close? I had to restart my whole computer system. I think I restarted it. But I went ahead in Super Slicer and I downloaded his extrusion multiplier little blocks here that have the extrusion multiplier written on the back, and I loaded them all from this one. And it was like there had to be like 36 of them. They wouldn't fit on the build plate. So I thought, you know what? I'm just going to go from 0.8 in increments of 5%. So 0.8, 0.85, 0.9, 0.951. I think I went right up to 115. And I went ahead and basically right here, as you can see, I printed 9 of them. And the extrusion multiplier factor is on the bottom of them printed. I haven't even pulled this off the bed yet. This just finished printing about 20 minutes ago. And so we're going to pull that off and see. And yes, in Super Slicer, I was able to go in Super Slicer and add the modifier for each piece to give each piece its own extrusion multiplier, which is really handy. I'm surprised Prusa Slicer doesn't allow you to do that, but that's what we're going to do. So let's go ahead and pull this off. And I actually utilized the smooth side of my PEI sheet as opposed to the textured side, just because I wanted to see how well things would adhere to the smooth side. And as you can see, it's nice and cool, and PLA is sticking to that smooth side really well. So let's actually, before I pop them off, I'm not going to even cheat. I'm going to bring a different camera in here, and we're going to look at the tops of them now. Even though I just bent it and loosened them all off, I'm still not going to turn them over and cheat. So I'm going to bring in this camera here, and let's see if I can make this camera. Boom, this one. Ooh, that's scary. And we're going to move that down to this angle. There we go. And if I move that to an even closer angle, here we go. Let's see if we can have a look. Now, just as a reminder, on the LS tuning guide, he does give and if I scroll down here a little bit, boom, boom, boom. Oops, I got to find it under tuning. And he talks, and he talks about, here, I'm going to show you what I'm looking at here. So, and I've got to go under tuning, and we are an extrusion multiplier. And he gives a graphic here of, these are just all the instructions on how to set it up and the settings to use. Then he gives a graphic here of what to look for extrusion multipliers. So you're looking at gapping, all the way from gapping to ridges, and then almost perfect in the middle. So we're going to look and have a look at these ones on the bottom here. So if I switch back over to this camera, we'll pull them up one at a time. And let's have a determining look here. And I printed them off camera because I didn't want to bore you guys with all the, the printing. These took about an hour to print. So if I look at this one, I'm trying to get it at the right light here. These all look not bad, but so we have that. We have number 1. So we're going to look at that. Did them in black because you can kind of see the flaws in black even more. So we're going to put that aside, number 1. And then let's just pick these randomly. I don't know what order these are in. And then I'm going to look at number 2, and this looks like it might be a little bit, if I had to guess, I'm seeing some gaps in the filament. I'm seeing some gaps. If I get it at the right angle. Hey, Mika Steve. Hello, sir. Let me find my little pointer tool here. So I am seeing some gaps with my eyes, but I'm seeing some gaps in around just it's really hard to duplicate this in the camera, what I'm seeing, but I'm seeing some gaps. And then down over here, you can kind of see some little bit of gaps and stuff. So let's eliminate this one as a possible good one. And let's pull up another one here. And if I take a look at this one without, this one's not bad, but I think this one is going to have, these are all really good. This one doesn't look too bad at all. So here, let's have a quick peek here. See, this one, I'm not seeing any gaps and I'm not seeing any ridges. You can see the layer under, you're saying, yeah. I've done 4, how many top layers did I do on this? It's too bad I had to reboot my computer. I think I did 4 top layers on this. So this one looks good. If you look at this, there's no gaps, there's no ridges, there's no over extrusion on that. So we're going to keep that one as a potential good one. Okay. And this guy here, this one here, I am definitely seeing some issues. We see some ridges, we see some bumping. Okay, that's definitely looks like it's over extruding. I'm going to guess this one's above 1 or above 100. So let's take a peek under and see what this is. Yeah, this is my first layer was a bit tight. This is 1.15. So that was way, and my first layer was really squished on this. But that's okay. We're not really paying attention to the first layer here. We're looking at the extrusion multiplier. So that's definitely too high. I knew that was above 1. So that one we can eliminate. Let's look at the other one we eliminated that had the gaps in it. That I saw the gaps. And I haven't looked at this yet either. Let's see if this is maybe like a 0.8 or a 0.85. Let's look. And yeah, that's 0.8. Okay, so that's definitely too low. Okay. And let's look at some of these other ones here. So if I look at this one, again, we've got some bumps. So you can kind of see it's over extruding in the middle here. So we do have some ridges. This is going to be above 1 again, I'm guessing. And yeah, we have 1.1. There we go, 1.1 on that one. Okay. And this one here, this one's pretty good too. This one's not bad. I would say if anything, this one's a little over extruded, because you can almost see right in this area here, like bumping, and it does feel a little more ridgy. So I'm going to eliminate this. I'm going to say this is above 1 as well. Oh, that's 1 right on the nose. Okay, let's eliminate that one. Here's another one here. That is, gappy. Again, hard. Yeah, you can definitely see, look at all the gaps. Okay, this is definitely going to be under 1. This is probably going to be in the 0.8 something here. And then, oh, that's a 0.9. So that's a 0.9 extrusion multiplier, too much. And this one here is actually pretty darn good. This one's not bad. A few gaps close to the edges here, just up here, up on the top part here. But overall, that's not bad. I would eliminate it though, because there's gaps as you get closer to the edges down here as well. So this is going to be under 1 for sure. Yeah, that's a 0.85. Okay, so we're eliminating that one. And the last one to look at is this one. And this one's not bad, but I'm trying to get the right camera angle here, guys. Again, whoop, and the right lighting. This one's probably a little bit over. I can see a few little bumps on this one, so it's probably a little bit over. So this, I'm guessing, is going to be 1.1 or something. Let's see. 1.05. So that is above 1 for sure. Okay, so we've narrowed it down to the 2 so far. So we've got, forget the little dust on that, but we got this one, okay, which looks pretty darn good. Okay, so there's number 1. Whoops, get the right light here. Okay, and then number 2. Personally, this is my favorite. Okay, so I like this one best. I think the little issues you're seeing there is I think I should have used more top layers, because it does tell you to use more top layers. But if you look straight on at the layer lines, oh man, it's the lighting here. Sorry, guys. There we go. Right. There's a good view of it right there. I don't see any gaps and I don't see any bulging. So this is the one, number 2. Okay, so let's look at what number 1 was. Number 1 was 0.925. Oops, was 925. Number 1, and the one we chose is, look at that, 0.95. So we could, oh, get in there. There's the one we chose. Lighting, 0.95. Look at that. So that's not a bad bottom layer. It's a little over squished, but it's not bad for a smooth bed. So yeah, 0.95, all that, just to say 0.95 could be our extrusion multiplier. Now we could narrow that even further, because he has them at the ones that he has that are pre-labeled. He has 0.95, 0.96, 0.97, 0.98, yada, yada, yada. You get the idea. We can now narrow this down, and we could go 0.941, 42, 43, right up to 0.959, right? But I think I'm going to just go with a 0.95 extrusion multiplier. And this is just for this filament. This is Polymaker PLA black. You could theoretically do this for every single filament, but I guess it depends on how specific you want your quality to be for each filament. Now, I can see doing it for, okay, we can do it for PLA and do it for PETG, do it for ABS, do it for et cetera, but I can't see myself doing this for every brand of filament I have, because I could probably couldn't count on 2 hands the different brands of filament I have, and that's a lot of extrusion multiplier testing and switching. Whereas if I just say, okay, for PLA 0.95, for PETG, it's et cetera. So yeah. So that's your default, and it works great for most filaments. Awesome. So you only tune if you see issues. Exactly. So it was a good exercise, though. It was a good exercise for a couple of reasons. Oh, and this comes off that smooth bed beautifully. So we're going to go ahead and print something else anyways. I want to clean this bed before we continue. It's a great exercise for a couple of reasons. It kind of shows you in real life, in a sense, with these little cube pieces, it shows you exactly what over extrusion and under extrusion look like and what they can do to your prints. And it gives you a really good visual of the bulging of over extrusion, and then of course the lines. And so under extruding, of course, when you see those gaps in the lines, you're not going to get a good layer adhesion and good adhesion between your filament, period, right? So, and it's kind of funny because the one that we tested last week was 0.95 with this gray filament, and it looked really good. So, and then of course running the ones that we just did now was 0.95. We picked out of, what did we say here? 9 of them. So out of the 9, 0.95 stuck out. So there we go. So I would say that is a successful tuning test. I'm going to keep these as a visual for a video I'm going to make on this. I unfortunately didn't have my camera rolling when I was printing these. That's okay. That's a gray one I dropped. And so we're going to adjust our extrusion multiplier to 0.95. What should I print? Now that doesn't conclude the testing. Now they also have his guide gets into some real advanced features. So if we come back here, let's move this camera up so it's a little more, boop, just like so. So if we come back to his guide, so there is our extrusion multiplier. Then he gets into pressure advance, oddities, and different things. So if we're having issues and we can kind of identify what they are, we can come into his tuning guide and read through it, and we can try and figure out what what's causing it, and go by his tuning guide and tune the things that are necessary. He gets into cooling and layer times. He gets into a lot of things that are not necessarily going to affect the average person, but I guess it just depends. If you're doing the PIF program, for instance, for Voron, you're going to want to tune this thing to the nth degree to make sure that you're putting out really good parts. Hope you're having a good night. Hey, Hayes Tunigan, I am having a great night. Your V0 kit just showed up, so assembly has begun. That's awesome. It's exciting. You're going to love the V0. Somebody, when I got the V0, told me that it's the hardest one to build, and I'm glad it was, because it makes these bigger ones a little easier to deal with. Did I reprint the probe mount for the ABS yet? No, I did not. The probe mount is still in PLA. Haven't had a problem with it at all. It's giving me, as you see, giving me really good. When I turned the bed over for this one here, I didn't adjust anything. I didn't adjust my Z offset, and it just gave me really good first layer based on that I'm still using the clicky probe. The Voron tap is supposedly going to be even more accurate for that. So we will see what happens there. So yeah, and then retraction. We all know we're all sort of familiar with retraction, why you need retraction, etc., what it does. So here he talks about fine-tuning retraction and what issues it can fix and how you can go about it. I tend to do retraction on a filament by filament basis, so I don't need to worry about that. Infill perimeter overlap. Again, these are all kind of things that you're going to really fine-tune if you find you're having issues with specific prints. And then I've not step over. I've not heard of this. More awareness. A lot of people don't know about it. Well, I don't know about step over. I'm going to look into it. Then he gets into advanced tuning, talking about volumetric flow rate. Now, he does have volumetric flow rate's interesting. I never really paid much attention to it, but I do now, because if you look down here on the approximate values, so on my 2.4, I have a Revo, which has a volumetric flow rate approximate value of 11. Is what they're suggesting. And on this one, I have a Dragon High Flow, which has over double the volumetric flow rate of the Revo, which at 24. It's actually one of the higher volumetric flow rates next to the Rapido and the Mosquito Magnum. So what that tells me is that I'm able to print faster, obviously with a little hotter temperatures, and my volumetric, my nozzle, or my hot end will keep up to the flow rate that's required to go those higher speeds, because it's got a higher volumetric flow rate. In other words, it's not going to under extrude due to the demand, the higher demand for the plastic to be pushed out at the higher speeds. So I wanted to go with the high flow. I've never had a high flow hot end before, so I wanted to try it and see, so that we can maybe push some speed on this thing. So then he talks about motor currents again. Determining initials, so you can do a run current command, a hold current command, all this stuff that I'm not really going to get into as far as the tuning goes right now, because he gets into great detail. And then speeds and accelerations. So we speed and acceleration, I tend to go with the profiles that are made, that are already preset and that have been tested and determined to work for these printers. But I will be playing with speeds, definitely be playing with printing speeds. Accelerations, I think once you set them and you get to know your accelerations, that they can pretty much stay the same. But is that a lifted corner on that one? On which one? Hey, RC Chapman, how are you, sir? Or R Chapman, is it a lifted corner on which one? Did I on I don't know. I had no lifted corners on any of these. Doo-doo. So anyways, yeah, so he's a lot of useful stuff in this, and he's moved his tuning guide actually to ls3dp.com. It was on GitHub before, and he's moved it to a separate website. So if you guys are looking for his tuning guide, definitely check it out here. So actually what I'll do is I'll just post a quick link here. So if anybody wants to go ahead and bookmark his tuning guide, it's a really good read, especially for tuning the Vorons. So there we go. There's his tuning guide right there. So yeah, that was a great experiment. So now that I've determined the 0.95 and we've got the he's got a super slicer profile available on a Voron as well. Okay, cool. And I don't use super slicer a lot. I use super slicer for this one because I wanted to print all these extrusion multiplier cubes at once, and I could individualize the extrusion multiplier in each piece, which was actually quite simple. If anybody, just in case somebody's not aware of how that works, let me just show you, because I kind of had to learn it too. I don't want to enter whiteboard mode. Stop picking up on my hand signals, camera. Bad camera. So if I pop open Super Slicer here, let's see, it wasn't open. I had to re-download, and oh yeah, it's encountered an error because that's the different version. I downloaded the newest version of Super Slicer, which is right here, and it should open up right now. Oops, helps if I double click it. And then if I go ahead and I downloaded all of his print tuning files, so we'll go to test print. So let's go ahead and share the display here. And if I open the extrusion multiplier cubes labeled, and I went to the 0.8 to 1.2, and you'll see what I mean here. Let me get my screen back up here so I can see what you guys are seeing. So his ones go from 0.8, 0.805, 0.81. So all these, and I tried to load them all on the bed, but it's way too many. So I just took a few. So let's just take a few here, and I'll show you how I got this to work. You guys probably all know this, but this was new to me. So I brought them in, boom, there's the cubes. And then, YouTube just notified you. Okay. And I had the stream posted earlier, Zen, but thanks for being here. And then we go here, we sort them on the bed. Okay. I happen to only pick, I only picked 7, but that's okay. And then again, on the bottom, we have all the extrusion multiplier cubes. So basically what we do is you pick one. Let's pick the 800. Oops. Let's pick the 800, right mouse click it. All the way to the bottom, we're going to add settings. We're going to add a filament setting. And then right there, just check extrusion multiplier, apply. Now you see over on the right, you've got your filament variable there. You click on that and you go down here. And then here you would basically go 80% extrusion multiplier and done. So that one, oops, I didn't want to slice it. Get back. And then same thing, you would pick this one, which is 8.83, right mouse click. Add setting, filament, extrusion multiplier. You can also change your retraction length, your temperature, or your Z lift override. So it's pretty cool. You can change all those things on the one piece. You go apply, you're right here, your filament, and that was 83%. And boom, that's done. So when you come into this one, it says 83. This one is 80, et cetera, et cetera. And you can go on and do that and add your different multipliers there. So that was really cool. I mean, Super Slicer is awesome for that. And I really need to get into using Super Slicer. I really need to get into using Super Slicer a little bit more, because it's got some really cool features. And it also has, well, let's go back into it here. It's got some test prints you can do too. And maybe let's run a test print from it, because I do want to run something right now. But before I get into running something, let's save ourselves a bit of time by going into here and starting the bed heating up a bit. We're going to run PLA because I don't have the covers on yet for ABS. I could run PETG, but PETG is pretty simple to run. And we're going to heat the bed up to 65. We'll get that going. And then in Super Slicer, if I'm not mistaken, oops, let's take that out. Let's Control A to select them all. Let's get rid of those. And I believe Super Slicer has some generate. I'm pretty sure I have some test prints here. Ironing pattern calibration, extruder retraction calibration, filament temperature calibration. They've got all these different calibration models you can do. And I know Richard from the first layer is always talking about doing a temperature tower, and I'm guilty for not doing temperature towers. So you can also build a bridging test using this method as well. That's awesome. So I've got to get into Super Slicer more just for a lot of these features. So let's see. Do I want to do that? What other calibrations do we have in here? We have bed extruder leveling. I don't think I need to do my, you know, although it wouldn't hurt to do a, no, because I think my first layers are pretty good on this. So there's another thing I got to look at, and I don't know if I should look at it before we do a test print. I'm going to do a quick test print, but my LEDs aren't working. Ellis should talk some about it, or at least he used to. Oh, okay. Yeah, and you know, sometimes these are not going to be necessarily the best. Oh, there's a bridge flow calibration. 10 steps, number of NB tests 5, test flow ratio. Oh, I see. So this is just a quick, so I close that now. So I see this is just a quick calibration of bridges and how far the bridges are going to go. Oh, okay, there we go. Anyways. And that's got very little adhesion to the bed. I'd be curious to see how that worked out. So this is going to calibrate the bridge. Bridges. If you do the calibration cube, you can pick the Voron cube. Oh, okay. Well, let's get rid of this. I want to print a quick test now that we've got everything, and I want to set it to the 0.95 extrusion multiplier. Calibration cube. Yeah, okay, made by Voron Design. What's this one here? I've done the Voron cube. Curious what this one is for. Let's see. 20 millimeter cube is fine. Standard or Voron or closed. What's a standard cube look like? Creating a new project. Yeah, I don't need to save the old one. That's fine. I've not seen this cube before. Oh, that's just a standard XYZ cube. Okay, that's boring. We know that's boring. So let's go ahead and do the calibration cube for the Voron. And no, we don't want to save that. Okay, there we go. What sort of print settings did it give me default? 3 parameters, which is fine. 6 and 5, which is fine. Infill of 30, no, 13. I'm going to go to an infill of 31 on this. And filament, we're doing 215 at 65 is fine. Yeah, 30 millimeters. 30 millimeters? Oh, is that the standard size for a Voron cube? 30. I want to print it fast. Okay, so we got to do it again, right? So 30 millimeter for Voron cube. Okay, we'll go that way. We don't want to, you know. Okay, let's pick 30 and go dimensional accuracy or infill perimeter overlap. I want to go dimensional accuracy, Voron cube. We don't want to save that previous one. There we go. Close that. Print settings should have stayed the same. No, we're going to infill a 31% gyroid. And 3, 6, and 5. I can get away with 5 and 5. 3 perimeters. Our temperature's fine. I want to adjust my speeds. So where's my speed? I want to speed it up from my default. Check the custom start and end under printer settings. Custom start and end should be my print start and my print end G code, which is what I want. It didn't change that at all. We're going to speed things up a little bit here. Let's do perimeter at 150. To infill at 200. Since we got the high flow nozzle, external perimeters, we'll go to 80, we'll double that. Sparse infill, go up. Top solid, we'll keep the same so we have a good top layer. Support speed, we're not worrying about support. Bridging speed, we'll leave standard. And under filament, I need to change my extrusion multiplier to 0.95, I believe was what we decided. Yeah. So 0.95 extrusion multiplier. Let's go ahead and save that for PLA. And according to this, it is 58 minutes to print that, but we can speed that up as we go. Do I have good enough cooling for that speed? We're going to find out. We'll see. If I did input shaper, set the access to the max. Set the accelerations to the max. Oh, what were my maximum accelerations? Oh, gosh. You know, I don't know if I paid attention to that. Let's go with what we got. Let's go with what we got. Print that, see what happens. We should start printing pretty soon because the bed is warm, but I got to clean that nozzle off. So I just have to clean. That's not what we want. That's not what we want either. We want this to be pointing right there. I'm going to clean the nozzle off a bit here because we're, there we go. I need to get a nozzle brush so that when it does the mesh leveling and the homing and everything, that I don't have filament sticking out of that nozzle. That's going to set accelerations to 0. To 0? Why? Yeah, I don't remember what my maximum accelerations were. Let's just see. It wouldn't. I don't think it tells me in the printer config, does it? Let's just have a quick peek here. No, it doesn't tell me the max accelerations. It tells me the frequencies and the shaper types. Let's see. Why is that? But hang on. Let's hang on. I'm getting warm here now, so hold on. I gotta do a strip tease. I'm getting a little warm. There we go. Whew. See, as soon as I turn the printer to heat up the bed, I get warm. But we got to stop the print here, because I just noticed something. I just noticed something that I probably did wrong. Let's stop. Let's pause you. It's probably going to go through its. I may end up having to redo the input shaper here because oh, thanks, Miles. Appreciate that. It's nice and colorful. You can run the code in SSH to make the charts. Check printables for the brush mount. You can cut down the brush included in the kit. Oh, cool. Yeah, and I will. I definitely want to make a brush mount. And it shouldn't be any more difficult than the clicky probe to configure the brush mount and everything. So, but one thing I noticed in here, and this is probably my fault, is if I go to my printer config, and if I go to the input shaper section, it's commented out. But it says do not edit block. Okay. Do not edit this block or anything below the contents are auto-generated. Oh, okay. So when I hit save config, so obviously the hashtag is auto-generated and it knows what my input shaper settings should be. Okay, I thought I had forgotten to uncomment my input shaper settings. Okay, so we should be okay. So forget it. I didn't need to cancel this. So I can actually go here and I can go back up here and I can unpause this. Well, I just hit pause. It's just going to tell me to play. That's the autosave section. Yeah, that's what I just figured. That's what the hashtag is doing for me. So we are, right now it's just doing its mesh calibration here. Let's see if I can get this other camera up here. Might show this a little nicer. Here we go. And this might be zoomed in a little bit big, but let's try that. Let's see. Oh yeah, it's zoomed in way too close. Let's zoom you out so you can zoom you out so far that you can see the dust on the lens. It's a little too far. There we go. That's better. You cannot stand that down there. You always put it up above real blocks and then delete the autosaves. Oh, really? Okay. You prefer controlling acceleration via the slicer. Ah, okay. I need to learn more about acceleration settings in the slicer. I'll be honest. I don't. I go with the defaults for the printer profile. So I need to learn to play with those a little bit more. Based on what I can do. Okay, so we're going to pause here because I had told it to pause. Oh no, we're still heating up. Maybe it's ignoring my pause command. Yeah, where the nozzle's just parked right over there just to heat up, and then it's going to start. Then it should start printing. Yeah. Okay. If you want to revert a save change, just remove it from the lower section, uncomment the previous setting in the original section. Oh, okay. So if I move it up to the standard section, it will override the autosaves. So if I move it up to the standard section, uncomment it and make a change, does that override the autosave section or does that throw an error? Okay, there's our purge line, and you're going to go pause, right? Yeah, you're going to pause because I told you to pause, but let's go ahead and play. And you got a big string hanging off you. Can I get that off on time? There we go. Okay. Not if you autosave again, as it overwrites the saved autosave. Okay, and you can hide the backups in main sale. Yeah, okay. Makes sense. You know, my fourth Voron build, and I'm still learning about Clipper and mainsail, and I'm still learning about the config files, and I think that I'll continuously learn about these things. So one thing I'm going to put out there to ask you guys, I don't remember on my 2.4 build, I don't remember where I plugged in my NeoPixels. And the reason my lights aren't working is because I don't have them plugged in. I don't remember where I plugged them in on the Octopus. So there's two wires. One of them's a 5-volt power. That was not a hand signal for you, camera. Stop it. One of them's a 5-volt power, and the other one is a signal. And I don't remember where I plugged them in. And I can't for the life of me find anything on where to plug in the two NeoPixel wires on the BTT board. I do have this graph here. Well, not a graph. I have a large print of the board because I'm blind. And I believe it's PB0 because there is a port here called J37. And J37 is for the RGB LEDs. And there's a PB0 and then one that says 5 volt or 3 volt. That's 3 volt. Or is that 5? I think that says 3 volt. Maybe that's why it wouldn't work for me, because I think I had plugged it into there. And I actually have to plug it into a different 5-volt supply. I have to use my cheater to see what that says. Oh no, that says 5 volts. But if I recall, and so basically that's the J37 plug. That says 5. So basically I'm looking at this. This is the LED connector here, J37. And we have PB0, which is what the config file says that it's plugged into, and then 5 volts. But I plugged them both into there and it didn't work. And if I recall on the 2.4, I had to plug one in there and another one in somewhere else. I think the signal wire went in there and the 5-volt wire went in somewhere else. So zoom into the LDO docks and you can see 3-color heat shrunk wires above the fan ports. Oh, okay. Yeah, it was a kit. It was the LDO kit, but I went with the 2-part PCB board for the hot end for the Stealthburner, and it was a Stealthburner upgrade. And out of that 2-part board, there's 2 wires that come out for LED, and basically it's the wires as a instead of chamber thermistor, it's the 2 LED wires. So, yeah. Love it when somebody knocks over onto the number pad of the keyboard. Something knocks over to the number pad. 3 plus 0.622 plus 3. Is that a math question? So that's 3.622 plus 3. The answer is 6.622. Zen, that's the answer. So zoom into the LDO docks and you can see the 3-color heat shrunk wires above the fan. Let me look at the LDO docks. Let me open the LDO docks here. Here, let's go ahead and share what I'm doing. Trident and wiring. So let's have a peek here. So yeah, I'm not using this PCB. I got the Hartic, whatever you call it, the 2-piece PCB. So let's go back. Let's go way down, way down, way down. There's going to be a close-up of the board here with all the wiring done. And I don't think it's this one. Part fan, hot end fan, Z-probe. There's going to be a final diagram of it all completed here, which is right here. So if I zoom into this guy, why are you not zooming in? There we go. See, there's nothing. The LED port is underneath these wires here, but you say, hey, HVAC. Hey, Sergio, how are you? And Chris Travis, hello. See, PZ dude, you would think so. You would think so, but and there's 3 coming out, and I think what's happening on those is they share a ground. Because on the 2-part PCB, there's only 2 wires that come out for LED. But on the LEDs that are wired into the Stealthburner, there are 3 wires coming out. And you're right, a 5-volt, a signal, and a ground, but I believe they share the ground through the common wire, the big batch of wires that comes out. I believe they share a ground. And so the 2 that are coming out of the LED plug on the second part of that LCD or PCB are the ground or the signal and the 5-volt, and they plug in specific places. Now, worst case, I can just bend over my 2.4, open it up, and see where I've plugged in the wires. But I thought, well, I should remember, but I don't remember. So click here above to get a better picture. Oh, right here. Okay. Oh, much bigger, much better picture. How do I scroll over though? Maybe just like scroll over, scroll over, scroll over, scroll over. Where's my bottom scroll bar? It's not there. Oh, there it is there. Okay, let's scroll over here and let's scroll up, up, up. Went over a little too far. Right about there. There we go. So underneath, so right click, open image and new tab. That'll work too. Open image and new tab. So underneath, where did you say it was? Just open up my 2.4 in the browser and look at the printer config file. It will tell you the pins you used. It'll tell me the pins I used for the yeah, one is the signal wire for sure, and the other is the power. I know that, yes. Underneath here though is so right underneath there is the LED port. It's the one right underneath these three right here, or these ones right here, kind of where you see the little red. So that right up in there is the LED port. I had plugged in the 5 volt into the 5 volt, and I plugged in the signal into the signal. At least I think that's what they were. And they didn't work. Now, that doesn't mean that that was wrong. That could mean that I have a problem at the Stealthburner end with my wiring. So, but I double checked the wiring, and I'm pretty sure the wiring was okay. But as Zenbender says, open up 2.4 in my browser and look at the printer config file. Well, okay, if I open the 2.4, which is right here, and if I look at my printer config, actually, and I believe I've got it in the NeoPixel config file, which tells me that my first pin is PB0. And definitely PB0 is, if I look at this chart, PB0 is the signal pin. So in here, there's the J37. I wonder if this will show this. Yeah, there's J37 in my right there. And PB0 is the middle one, which should be the signal pin. And J37 is right there. And then PB0 is the middle, which is the signal. But for some reason on the 2.4, I swear I ran that. I didn't plug in my power to that. I plugged it in possibly to one of the fan ports or a different 5 volt port somewhere. So, yeah. So I'm not 100% sure how I did that. Now that's the NeoPixel LEDs, but then there's, yeah, and that's also going to control the hot end LED as well, like the nozzle LED, because they're all wired to the same thing. So yeah. Okay, Jose Ferreira, thank you so much. I appreciate you coming by. As always, thank you. You have a good sleep and a good night, and we'll see you next week. And we'll see you on the other streams. I see you on everybody else's stream as well. Yeah. If you have a 2-piece board, upgrade, look at HARC 1213 repo for the updated wiring. Let me Google that real quick and see what's going on. In the meantime, I can give you guys a look at what's going on here in the cube while I look that up. Do I have the lights on? Let me turn the case lights on full here. See if that brightens that up a little bit more. There we go. Brightens it up a little bit. Just without the nozzle light, you can't really see what's going on. And for some reason, I can't get those flipping things working. Well, I know why I can't get them working. So let's see. You said to look up. It's the 1 point. I think it's the same as I had before. Same version I was having the 2.4. I'll have to tip this over and have a look at it after. You thought they fixed the 5 volt, 3.3 volt signal wire issue, which is probably why I had to run the 5 volts from a different source on that. I would assume it's the same because I think that LDO has gotten, you know, they sent out the kits whenever, and they probably haven't updated to the new boards at that point. So 5 volt goes to the CT on the breakout board. Oh, on the breakout board. Okay. Okay, I'll have to look at that. 5 volt goes to the chamber thermistor on the breakout board. Oh, okay. So the 5 volt goes there, and the signal goes to where to the PB0. Signal wire voltage is different. 5 volt power supplied to the light. Oh, I see. Oh, the signal wire is 3.3 volts. Is that what you're saying? That's what PB0 is doing. It's giving us the 3 volt signal, 3.3 volt signal, and the 5 volt is to power the LEDs. Okay. Neil, that's good to know then. 5-volt goes to the CT on the breakout board. I knew they went to different places. So I will try that when we finish this print. How are we looking? We're looking pretty good, actually. We are looking pretty good. I wish I could, actually, I can show you a better, I have this really cool magnetic flashlight with a nice, but will it stick to anything here? Oh, let's see if I can get this to shine a light for you. No, see, but there we're getting a better look at it. But we're looking good so far. I definitely need my nozzle lights. Okay, 2-piece is not directly compatible with the LDO breakout. Okay. Okie doke. I swear, every build I do, I learn something new. So every build. I don't know if it's possible to know it all unless you're the guy that developed the Vorons and Clipper and all that. So it's moving pretty slow for a Voron. It's just doing a cube with infill, though. I mean, I can speed it up. I just want to see how good the cube looks at standard speed. Mind you, I do have a high flow hot end. Oh, I didn't change the flow rate in the slicer, did I? Oh, shame on me. Where's the flow rate? Volumetric speed. Oh, I didn't change it. I left it at 13. I could have gone up to 24. Yeah. I can still speed it up though. But it's not going to give me the, not going to show me the, if I speed it up without increasing the flow rate, it might give me not as good a look at the quality I want it to be. So, oh, you posted a guide to make it work on LDO breakout boards. Let me look that up and just see while we're watching this. Part K1213. Let me look it up and see if I can find it. Okay, 2-piece PCB Reddit. Let me have a look here. Okay, I've got all, so far it's just showing me Afterburner, Stealthburner toolhead PCB, share part of PCB way. Nothing is showing me the wiring on an octopus. But I think that I really think that that Neil has it where it goes to the 5-volt and the chamber thermistor on the breakout board. Okay, if you ran input shaper, then in your slicer, you also need to update the accelerations you want to use or turn them off and tell it to use hardware accelerations. Okay. Yeah, I should be going quicker, shouldn't I? Let's see, what acceleration are we set at right now in the we are going at maximum acceleration 1500. I'm sure I can get away with more than that. And we're at 300 millimeters a second on the set, but we're not hitting those speeds, obviously, because we're just printing a small cube. Angry Rabbit Carrot Feeder, MMU. I don't know. Chris. My next project for the Voron is going to be the Voron tap. You wired 5-volt and signal to the NeoPixel port using the SB PCB with no issues, but I'm not using the LDO board. Okay, yeah. Yeah, well, and that's what I've learned. So in the slicer, for instance, in Super Slicer here, if I go to the speeds and down to acceleration control, so here's my acceleration controls here. So I am, default is at 3000, perimeter is 2000. First layer acceleration should be slower, obviously. We're at 1000 in the first layer, 1500 on travel, 3000 on bridge. We have 0 on support and 0 on infill, on solid infill. But yeah, these are numbers that I don't play with much, but I want to learn the proper way. So obviously my default acceleration should be what my maximum acceleration is allowing me based on my input shaper results. And they're very conservative. Yeah, okay. Okay. Yeah. Then I have my volumetric speed. And then my volumetric flow under filament is set right now at 13 millimeters per second. And again, according to the Ellis guide, I can be around 24 with the high flow hot end. You can download Ellis's profile and use that as a guide. Okay, let me find that. Let me go to Ellis's page. Let me find his profiles, my Super Slicer profiles right here. Let's go ahead and have a look at those while we're here and see how different they are. So Super Slicer, Core XY speeds, input shaper, Core XY speeds, no input shaper. So we have input shaper. High flow hot end right here. Look at that. Standard flow, ultra flow. Okay, so we're going to go high flow and decorative 45 degree, decorative standard, LSPIF 45 degree. Oh, so he's got the printed forward settings here too. 10,000 accelerations. Okay. 0 just means use the default. Okay, fair enough. So what does it mean by he's got decorative 45 degree and just standard? So what does decorative 45 degree mean? Keep in mind his profile is for a high flow hot end though. Well, I have a high flow hot end, Zen. This is a Dragon high flow that's in this printer. Then we have a PIF 45 degree. Near the bottom of the page. Yeah, we've got that. That's going to lead to his page right here. Page is moved. Yeah, he's moved that page. So ultra high flow. I don't have an ultra high flow. I have a high flow. So it's these profiles I want here. He explains in the root folder. Okay. Oh, I see. Right here. Okay. Okay, let's just, you said near the bottom. With input shaper. Static fan speeds. Okay. Oh, I see. Okay. Okay, here we go. Okay, primary profile is 45 degree profile. Orient STLs to be at 45 degree angle. Oh, okay. Okay. Okay, so basically rotating your parts prints at 45 degrees. So there's a profile for that and a profile for printing standard. Okay. Seam placement. Okay. because he can locate the seams and the corners of the pieces versus the sides of the pieces. That makes sense. Versus corner seams. Oh, I get it. Okay. Oh no, he wants them to be scattered versus being in the corner. Okay. Okay, makes sense. Okay. So the 45-degree profile is if I want to switch and turn my, I've got to read through all this. I've got to read through all of this. Man, does he ever get into detail, doesn't he? Okay. That kind of makes sense then, why the 45-degree one. It's a lot of reading, but it's a matter of how much I want to learn, and I want to learn it all. I want to know everything. Ha ha ha. So if we do super slicer and we do input shaper and we do a high flow, I basically can get away with, actually, why don't I just go back here? Why don't I just download a zip file, and then I have everything in the zip file. Okay. Yeah, I got some reading to do, people. So if I open Super Slicer, and if I go ahead and find those folder I just downloaded, oh, it's a wealth, and there's so much to learn, and my brain can only handle so much at once. I have a small brain. Don't go there. Let's go to my download folder. Let's go ahead and move that to my desktop. Let's uncompress that zip file. Profiles master. It's a good thing there's people like him out there that share all this stuff, right? Like, okay, so now if I open that, okay, everything's in there. So now I should be able to go file, import, config. Let's just discard all that. Let's import the config. So go to my desktop, go to Super Slicer's profile master, Super Slicer, input shaper, high flow, and decorative standard. And let's do PIF standard. Let's skip. You know, what the heck? Why not just import them all? Can I import all at once? No. I have to do one at a time. And it opens it from that leg. 250 afterburner. There we are. Decorative. So I'm curious on this print setting. Oh, okay, so there's some better. Look at the accelerations for that one. There we go. That's different. Yeah. So this would give me faster printing rate now. And our volumetric speed is 24. Yeah, okay. There's all the differences right there. I think I should stop this print and start it again with his settings. What do you think? There's my filament settings. That's a little high. He's got, what filament is this set for? ABS. I want it set for PLA. I can just change. I don't want it, but I want to keep that. I want to keep that. I can change my filament settings and just save it as a PLA setting for the same profile. Chamber temperature is irrelevant because I'm not using a chamber heater. His are for a 350. Mine are for a 250. Yeah. Printer settings, machine, general. 250. Oh, this is 250. 250, 250. Yeah, I just changed it to my printer and his settings stayed. So my filament settings are okay. My cooling, maximum default fan speed, I want PLA. I'm going to go on 100 on PLA. He had it set for ABS. So we can save that one. And so his accelerations are all there. His volumetric flow is there. And the filament, volumetric maximum, oh, that's print speed override. We don't have to worry about that. I'm going to leave everything default for him from him in here. I'm going to give us, we'll do our 31%, 3, 5, and 3, 5 and 5, 4 and 4, 5 and 5. And I'll do a skirt and a brim. Now, his should be a lot quicker. No, it's a little longer. Actually, he's got support. Why is there support material in this? I don't want support. None. We don't need support. It's about the same print time, but I didn't change my speeds, did I? No, my speeds were still at 150 and the slower speeds. So if we went to 200, what do you think? 200? Actually, I'm gonna leave the defaults, and I can speed it up on the printer itself as it's printing. Probably don't need that much infill on this either. No, it's a lot of infill. Yeah. Just non-Voron PIF settings. Okay. I can try his PIF settings after as well, but I just want to see how this looks. Mind you, it's going to take about the same time as this one is. See, I see some... It's probably could be my light too. I'm going to say I see some ringing there, but it could just be the way my light's hitting it. How does it look without the camera? Oh, without the camera, it's fine. I don't know. These cameras sometimes, and the way the angle the light hits, I throw shadows. Okay, let's speed this up, and then we're going to run his. I'm going to crank the speed on this guy a little bit. See if that makes much difference. Probably won't, because I didn't. My accelerations are going to stay the same. Maybe I should just cancel and start his. Because I want to have a look at the LEDs on this stream as well. Try and get the LEDs working. Pressure advance is set. It should be set because we did a pressure advance test on it. We still have, where did I put it? We still have the piece here. We used his newest test. This guy right here. And it was determined that we were at, I believe we ended up at 0.35 for pressure advance. Or were we at 0.2? Yeah. Just binge watching Poor Boy channel. Hello, sir. I would love to check out your 3D printed drone. Yeah, we ended up, I believe, at this, we were at 0.35 is what we had determined on this one. I could go a little higher because I was torn between 0.35 and 0.4, which would get rid of a little bit of that bulging. But let's make sure. Let's just make sure that I actually did go in and set it, because you know me. Just because I said it, it doesn't mean I necessarily set it. Let's get rid of that and let's find extruder. And let's see what I have my pressure advance set at. Pressure advance is set to 0.03. And I thought we had determined 0.035. Well, that could be part of the issue with that little bit of bulging happening as well. Let's have a closer look at this now that we have a bit of time here. So let's just look at this a little closer. It's sometimes easier to see on the camera. Isn't that a nice view? It's almost like I just totally got rid of my background, which I did. So 0.03. 0.04. So definitely at 0.04, we start getting bigger gaps. So we're definitely not going to do that. We got some major bulging at 0.01. So I think we had determined 0.035. So I guess that extra 5 after the 0.03 might make a little bit of difference for what we're seeing on that print a little bit there. 0.25 looks better. But on 0.25, let's see if I can't. So 0.25, whoops, wrong way. It's kind of mirrored. So you're saying, oh, sorry. You're saying right there, but there's a little bit of bulging on that right there. So right above there is 0.25, or is that 0.25 right there? Oh, that's 0.25 right there. That's 0.3, which is where we're at right now. And then this is 0.35. So we got a little gap happening at 0.35. So we're at 0.3. So if I go to 0.25, it's going to cause a little more bulging. Now, that said, this was a no-name filament that I've never used before. I don't know anything about the filament. It was sent to me to test. Maybe I should be running these tests on a filament that I kind of trust. I don't know. And I'm not blaming filament on giving me an inaccurate print. I'm just saying, oh man, stop the freaking face following. This little camera right here has hand gestures. I'm sure I can turn hand gesturing off. There we go. Why is that zoomed in? That should not be zoomed in so far. This should be like, just like that. There we go. Scary. So I don't necessarily want to go down. If we're getting a little bulging in the corners, I don't necessarily want to go down any further. Because, yeah, I'm trying to remember which cube was the second one out of these two. I believe it was... Yeah, this was the second cube here. This was after pressure advanced tuning, this cube. So we do have a little bit of... If I show the corner, hang on. Oh, man, there's not a lot of bulging in the corners there. There we go. Little bit, though. The corners don't look bad on that at all. Well, I guess right there could be a little bit of bulging happening. But again, I'm not a fan of the... And maybe I need to run input shaper again and use a different... Because I still see some ringing right there. A little bit. So, yeah. Just give it a universal hand gesture. You just took a look at Ellis Tuning Guide. What's interesting is that he and you think alike in some things, like choice of fans, using the speed to determine... Speed test to determine the maximum acceleration and some other things. Yeah. Oh, thank you, Poor Boy Channel. I appreciate that. It is. Oh, the light, and it's the light and the camera angles and everything that cast shadows. Like you look at the, and the more I turn it, the worse it looks as far as the ringing goes. I'm not happy with the smoothness of the layers, but again, I want to see how this cube turns out with the Polymaker filament. I know nothing about this filament, whether it was dry, whether it was wet. This was the no-name filament I ran. And then if you look at this filament, which was Jesse, oh, this is Polymaker Red. This is before I did any tuning on the printer at all. Come on, focus. And those layers are much cleaner. Look at that. We definitely have some ringing, but look how clean the layers are with no tuning compared to that gray filament, right? So I'm definitely going to say that, yeah, filament could have been a bit of an issue with that other one, but this was very first print off that printer, pre-tuning anything. So I'm not putting a lot of weight on the gray filament, hence why I'm running Polymaker Black right now. So, because filament can change the quality of your print. If it's a poorly made filament, if it's got some moisture in it, yeah. So definitely. So I'm hoping, you guys, sometimes you see me squinting, and you know, I've got new glasses coming. Hopefully, knock on wood, this week I get my new glasses. These are 11-year-old prescriptions. A year ago, I decided to stop wearing contact lenses because I had a scare with an eye infection, et cetera, blah, blah, blah. These are progressive lenses, and it's the wrong prescription, and I struggle every day on my computer screen to see with these things. So I finally, after another eye infection at Christmas last year, December just passed, when that was all cleared up and the scarring had all cleared up, I got an eye exam and determined, yeah, these are definitely the wrong prescription. So I got new ones coming in. So I'm going to be able to read things a little easier, and perhaps I'll be able to look closer. I can't get an accurate close look at this cube without using the camera because these are the wrong prescription, and the reader portion of these prescription is way off. So, yeah. Yeah, I agree. I should do a pressure advance on this filament. Theoretically, you should do a pressure advance, yes, on every single filament. I suppose, but I think there can be an average number I could use for average number for all PLA, average number for all PETG, etc. If I'm doing prints for a client, and accuracy and sharp corners and perfection is key, and fit and everything, then yeah, you want to definitely take, okay, I'm going to use this filament. Let's do all the testing and calibration of this filament to get this job done. Then absolutely, definitely. But I think for general purpose printing, for the hobbyist, for doing tinkers, for printing whatever, come up with an average pressure advance, an average extrusion multiplier, et cetera, and you get good enough prints for that, which are really good prints on a printer like this. But if you're doing, again, stuff that's got to be extremely accurate for a paying client, then you want to be doing a lot of these tests. I agree, PZ dude. Don't let good enough be the enemy of perfection. Trust me. In the business I'm in full time, printing and sign industry, I am anal when it comes to quality of a print product, quality of a decal, quality of a sign that I'm mounting on a wall, et cetera, et cetera. I just did a whole bunch of wall murals for a customer. We did a massive wall mural job, and I was extremely particular with the lining up of the images when we're doing multi-pieces and stuff. So I'm a perfectionist when it comes to that. But I'm saying that I will only spend so much time calibrating a filament for a specific job. Like I did a bunch of stuff here. This is a paying job for a client. I don't necessarily have to explain what they're for, but this was a 2-color job. Really quick filament change. Quality is really good on this. Now, it could be better. I could have used a 0.1 nozzle for the letters and stuff, because basically this job entails all these pieces, okay, and the different times on them and so forth. But this is good for what this client needs. Okay, and some people may look at this and say, well, you could have done better. I mean, look, the bottom layers are really good. Text is easy to read. Top layers look really nice, etc. Somebody could say, well, I can do better. And you can. I could have gone ahead and this is a different printer. We're not going to get into that other printer because it's all the hot rave printer now. But anyways, yeah, could it have been done a little better? Sure, it could have been done a little better, but by doing more and more and fine tuning. But I only want to spend so much time on this job, and this is, the client will not know the difference between this and if I had changed the extrusion multiplier by 0.1. You know what I'm saying? So, and not that I'm settling for good enough, but in a way I am. This, to me, this is an excellent job for the job that it's going to be used for. So, but PZ dude, I completely understand that, because if you let good enough be the enemy of perfection, I see what you're saying. But if I say, you know what, if this was crappy, it's good enough, you know, it's good enough. Like when I first ran this, I had one of these had a little bit of a layer shift. Just on the green, it had a little bit of a layer shift, and it was like, I was like, yeah, you know what, they won't notice, it's fine. But then if you do that, then the next time you're on a job, you're going to go, oh, it's good enough, and then the quality will slowly get lower and lower and lower, and your standards will lower. And that's what you got to be careful of, is not letting your standards go too low, especially if you're doing this in a pay-for-print environment. If you're selling a product, or even on a channel like mine, if I'm showing how this is good, I'm not going to say, I'm not going to go ahead and say, oh yeah, you know, these, you know, that's good enough. The average person's not going to see that, you know, look, oh, those aren't bad. It's good. No, I want to strive for this over this. So I see where you're going with that for sure. And that's a dangerous trap to fall into. You use 1 or 2 brands of PA Life filament that work with your PA. Yes. And I'm trying to narrow myself down to just using specific filaments. I can count on one hand the filaments that I trust to use. A Polymaker is one of them. 3D Fuel is another one. There's a few filaments that I have on my shelves back here. Prusament, you can't go wrong with Prusament, because we know the quality control they put into their filaments. But there's a handful of filaments. I was going to say unfortunately, or fortunately, however you want to say it, I've got a crap load of filament. I mean, you can kind of see in behind me, I've got tons of different filaments from when I was starting this hobby. The green filament on here is a neon green filament that I've had sitting around here for 3 years, unbagged, unopened, and it worked fine. and it's a decent filament, I probably won't ever buy that brand of filament again, but it worked to do this job. So yeah, but I'm trying to narrow down that I just have a handful of filaments. Now, if a company like these guys send me a roll and say, can you try our filament? Yeah, I'll give it a try, but I'm also going to give it an honest thing and say, hey, listen, this filament compared to another filament I used, doesn't quite cut to what I like to see as my minimum standard quality for a filament, especially on a printer of this caliper. So Prusament is expensive. It is. No question about it. That's why I only have, I think I can count on one hand how many rolls of Prusament I have left over. So, yeah. You print all your Polymaker ABS ASA using your KVP ABS settings. There we go. I gotta admit, I love Polymaker filament. I've gotten in a partnership with Polymaker, with Nicholas and Polymaker, and I love, not because of that, I can say whatever I want about these things. That's the kind of partnership it is. I don't have to go, oh, it's the best filament ever going. But no, I love the filament. It's printing beautifully for me. It just works. I also love 3D Fuel. I love that filament. It's incredible filament. I like the Sparta3D Sparkle ABS. That stuff prints, all these filaments, they print beautifully. And then I use, if I'm doing a rainbow or if I'm doing a silk, I like the Arion silks. They're not necessarily the best quality filaments out there, but for the particular properties I want, like a rainbow or a silk, they're good enough. They work. I think it's one of the better rainbow filaments. This was done in Arion's rainbow filament on the Voron 2.4. Is it perfect? No, I could have used adaptive. What's the word I'm looking for? I could have, you know what I mean. Adaptive layer height, for areas like that. But for the most part, that is for what this model would be used for. You're going to give this to a kid. You're going to sell this on Etsy because you're a patron of this guy's and you're allowed to sell the models, etc. Nobody is going to look at that and say, well, you could have used adaptive infill. You could have used adaptive, layer heights, etc. It would have been a little better. Nobody's going to get that fussy with that, right? So had I run this with a different brand filament, single color, would it look any better? I don't know, possibly, but I don't need to know. But all I know is that is a great print for this, printed on the 2.4, and I was quite happy with that print. And that's one of my favorite rainbow filaments. So yeah, he is cute though, isn't he? So yeah. Matter Hackers ABS, yeah. You'll take a sponsor from them. Try TTY 3D. There's so many companies out there. I agree, PZ dude. Yeah. Little signs were done. Hey, look at that. David Wilson knows his stuff. Yeah, these were done in a bamboo. These were done in the P1P with me adding a pause layer. I ran 12 on a bed or something. I added a pause layer, changed the filament. I do have the AMS coming. It would have been a perfect job for the AMS, but I don't have it right now. So yeah, these were run there. Good eye, David. Good eye. Good. I sound like Kieran Clark. Good eye. Every time I say good eye, I think I'm saying good eye. Good eye. Anyways, whatever. Have I named it yet, poor boy? No. Whoa. Knocked my cameras over. I have not named him. He's Yeti. He's got a flat back. Look, is the first layer perfect? No, look at that. I had something on the bed right there. But otherwise, the first layer is really decent. But again, nobody's gonna critique that. I haven't named him yet. I've got him, and I've also got he's got a twin brother named Goldie. His name's Goldie. So we have Goldie. Maybe I should name them Goldie and Locks. Goldilocks. Anyways, they watch each other's back. Here we go. And again with the rainbow filament, here's another perfect example of why I love the rainbow filament from them. You can probably look over this and find lots of different, where you might have gone, oh, I might have, decreased my acceleration. I might have yada yada yada, but it's a good overall print, and it would look different in a different brand filament, right? So yeah. Goldie and Han. Good one, Andrew. Good one. Golden Jaguar, you're getting a P1P with the AMS just for MMU prints, and the Bamboo lads did great with MMU. Oh, did they ever? Yeah. I've got a design yet. So part of this job, so what's happening is these are going to be, here, I'm going to put this on here. These are key fob tags, and it's a fob. The building I work in, I do a lot of work for our landlord, both printing and stuff, and we're starting to do some 3D printing for him. But the building I work in, whoops, I just dropped it. It's going to have a split key ring go on here, and then it's going to have a little fob, which is to access a golf simulator. Okay, and then the golf simulator is going to be accessed during certain times of the day only. So this one, the fob you would get on this will only give you access for these 2 hours. Anyways, I also need to design a case that these things go in so that the security desk that is going to be managing these things, they have a case that this goes in, this comes out, a driver's license goes in, here's your fob, blah, blah, blah. So I got to design a case. So anyways, this entire job, I mean, we all know that how much this filament would have cost, right? It's the design aspect of it. It's the CAD time of this, and it's the CAD time that I'm going to be using for the case. Pretty much is going to pay for the AMS. So yeah. And the AMS will run this job even, more efficiently than me having to sit here and swap filaments. So can do a filament swap on here. I could have printed it on this printer, no problem. Just as easy. Oh, that's looking good, that cube. Here. Where's my light? Man, it's hard to get a good angle on this thing. But the cube is looking really... Oh! Don't hit the hot end with the cube, with the light. But look at the cube. The cube is looking good. Anyways. Yeah. Andrew Humphrey related to Brian Vines. Fabulous. Why, is that something Brian Vines would say? That's good. Oh, I just read that. Fabulous. There we go. Look to printables for a Y adapter for the Bowden out of the buffer. Is that something I should look at too on the P1P for the AMS, David? I'll be getting a hold of you anyways, David. You've got both those printers, if I'm not mistaken. You've had a little bit more experience than me. Wait, why is there a body under the bed? I just saw that, Leo. There was a body under the bed. Yeah, he died. He got squished. I have a bad habit of putting stuff under here on the rat rig behind me. I don't even know if you can see it from here, but anyways, on the rat rig behind me, if you look at mind you, I've got to upgrade the rat rig and everything. If you look at the rat rig behind, look at all the junk I got underneath the bed on the bottom of the rat rig there. That's a bad habit to get into. So, yeah. I got to work on that. Oh, and then I got more filament just up over here, too. That's where I keep all the 3D fuel filament right up over there. Some 3D fuel, some Matter3d stuff. All kinds of filament hanging around. I need more filament storage than I have. So, it just kind of gets thrown everywhere. Come on, camera. and get back over to where you were, right there. Let's see. Did the link go through? I'm a dad joke guy. I am. Yeah, this is a great light. Nice thing. I got this for Christmas one year. I think it was last year. The beauty of this, I'll show you guys this. Not that this is a stream about lights, but what the heck. Is you get with this these heads. Okay, so I can take this here. Whoops. It's also got a bunch of settings on it. I can pop this head off, put this head on, and it's your standard flashlight. Or I can pop this head off, put this one on, and it becomes a flexi light. So I can flex that any which way I want. And it's got a magnet on the base. Yeah, it's pretty cool. I'm a flashlight. Am I allowed to say this word on YouTube? But I'm a flashlight whore, if you want to call it that. I used to collect flashlights. I've got tons of LED flashlights. This also comes with a little hook to hang it. And I love flashlights. And when I got this last year, it was like, holy crap, this is the cat's meow, this thing. It's a quality light. And I think this was from Costco, if I'm not mistaken. So, but it's my favorite, one of my favorite flashlights. I shouldn't say favorite. I have a lot of high-end ones over there that take some massively big batteries that can light up the night. Look for 30808131 on printables. Oh, sorry. Okay, David, go ahead and where's David Wilson in here? You can post that link now, David. This stream is lit. Yes, it is. Great spot for spools after enclosed. Oh, yeah, here. It's called a Flashaholic. Yeah. I could show you some of my flashlights, but did you mean aficionado? Finally found a flashlight with a unique feature of turning on when you hit the power button, then turns off when you hit it again. Those are rare, aren't they? Okay, so David posted that link. Let me have a look at that, because that's probably going to be something I'm going to need to look at as well. Let me have a look at that. Let's just see what we're looking at here. So let me go ahead and push that over here so we can share and share with the class. Share with the rest of the class here, shall we? Right here. Okay, so Bamboo Lab Y splitter with PC4 M10 pneumatic connector magnets. Okay, is that something we need for the... Oh, I see. And why... What's the purpose of that it wouldn't come with? Or is that just strictly for the X1? Or would it be a P1P thing as well? Interesting. I'm going to keep that link. So is that basically for anybody with an MMU, David? Oops, wrong screen. There we go. We're almost done this cube. Then we'll have a quick look at the LEDs. Let's see what we're looking at here. Looks pretty clean from here. Can I get that at an angle to show any layer lines? It just depends on the angle we go at. Yeah, it's looking good. We're just about done. This particular cube. Then I think otherwise you have to manually hook every time to switch from manual. Oh, I get what you're saying. Okay. It's like an adapter so that if you're going to feed from a roll or feed from the AMS. I get it. Okay. I think I'm going to print the, I wasn't sure if I was going to enclose this printer, but I think I will enclose this printer. It's always good to have another printer to print ABS parts on, etc. Okay, okay. Thanks for pointing that out, David. I will definitely be looking at getting that. I should print that in advance, actually. What material is that? Needs supports and all that stuff? Yeah, I'll figure it out. Actually, let me download it right now. Oh, man, they have a whole bunch of them. 6x3, 6x2, huh? Oh, 2.8 millimeter, 2.8 millimeter. 5x5. What's the difference between? I got to read up on them. Oh, it's for the different magnets. Oh, I see. For depending on what size magnets we have. Ah, okay. I was going to say what that. It was confusing. Ah, there we go. Look at that. Finish print. Overhead view. Here, let's do the zoom in on the overhead view. Ooh. Okay. What about this view? Oh man, that camera's way off. Okay, that sucks. Let's just stick to this one. Oh, I like the smooth surface of this PEI sheet. It's pretty good. It sticks really well, and there's no lifting on the corners at all. And the cube looks pretty good from this angle. The corners do look bulged though a little bit. So mind you, I didn't change the pressure advance in there yet. Although that could just be the way the light's hitting it too. But we'll measure it and get and see how accurate it is. And let's see if I can get I'll let that cool off before I try and get that off of there. Let's have a look at this cube. It's not bad. Again, the layer lines are so much better than that gray filament. Come on, focus. Black is hard to show sometimes. Here, let me pull this over closer here. Let me, there we go. Yeah, I think I need to run my input shaper again because I've been moving this printer on and off the Lazy Susan, right? So, and yeah, you can see a little bit of bulging in the corner. So I do have to adjust the pressure advance a little bit too. It could still use a little bit more tuning here. Where's the bottom? Bottom layer looks fine. Top. Y. Keep in mind, I'm very close to the camera. But I do definitely have some ringing happening still. Yeah, you can definitely see it right here. Yeah, I got to lower my pressure advance for sure. And I've got to do another, it could be the input shaper I'm using. I'm using two different ones for X and Y. I'm going to run it again and see what happens. Anyways, for now, but that's, again, that's day and night over the quality of this cube. If I just on the on the surface itself overall, I can't get the gray one to show up too well there, but I'm not happy with the finish on that gray one at all. But again, depending on the model you're printing with it, you might not even really notice it that much. But good enough is not good enough when it's not. Oh, you don't use any magnets at all. Okay, so let's have a quick peek down here. Let's see if I can't. Let's get this skirt off the bed, and that just peels off so clean too. I like that. I like that surface. Oh, that bed's still a little bit warm. Come on, come on. They need lining up pins on this thing. There we go. I missed the line-up pins like you get on the Prusa and on the Bamboo. You had a failed print over the weekend. It shifted while you slept and then righted itself. Weird. Layer shifts. You gotta love them, especially when you're 20 hours into a 21-hour print or something. Okay, let's turn these LEDs down a bit on here, because that's awful bright. That's better. I'm going to tip you over. Actually, I'm going to let you cool off, and then I'm going to power you off because I want to tip it over and I want to see about getting these LEDs working. And if I can't get it working by plugging it into the right plugs, then it's possible I have an issue with the wiring on the hot end. I don't think I do. I was very careful with that, though. So, okay, David, thank you so much. Appreciate you popping in. I'm going for another. I usually go till 8 o'clock, so we're only 2 hours into my 3-hour standard stream, but doesn't mean that I have to go 3 hours. Just if if I start seeing the viewership go down to 10, 5, 3, then I'll take the hint. So, how many likes do I have on here right now? We have 32 watching and 26 likes. That's not good math, people. Okay, so I was going to open up the, so we have the Voron, we have the, oh no, I need the PCB. Okay, I need to open up the drawing of the PCB on the LDO wiring diagram. There we go. There we go. So where's that PCB? There it is there. And hot end X. And then we have this one. Okay, so I'm going to turn this over in a second here. Let's just get rid of the filament for now so I don't have to worry about this roll popping off. Okay. And then I'm going to actually print an actual something on here as opposed to a test cube, etc. But I do want to run, I am going to run the pressure advance and input shaper once more. Okay. We are down to, why did I hit, shoot. I didn't want to do that. I did not want to do that. I hit the wrong button. Come on. Start up. There you go. I hit the wrong button by mistake on the touch screen. Extruder's at 50, beds at 50. Extruder at 50. Yeah, we're good. We're good enough to shut it down now. So I've learned now to go over here, hit the power and go shut down. And that way I don't, and then we're shutting down, and boom. Because people cringe when I shut it down without doing the shutdown, because they say you can kill your micro SD cards by doing that. Oh, that's good, Golden Jaguar. Yeah. I had a layer, as I say, I had a layer shift on this one piece. But that was one layer shift, which is weird. So who knows? So let's go ahead. Let's unplug this. Let's turn this on its side. Nothing on this side to break. I got to be sure I don't turn it on the front side or the side or the back side. It's got to go on this side. Okay, so yeah, here are my, and I've got to separate this now. So this is the wire coming from the LEDs on the PCB. So, and then if you look, if I get this really close, come on, wire. There we go. So right down. Why did you just do that? There we go. So right behind here, this red port right there, that's the LED port. That's the RGB LED. So the middle one is the PB0, is pin 0. So the only thing that I'm not sure is which wire, the white one or the black one, is the signal. And I think white is the signal, black is my power. I'm pretty sure I have white as the signal and black as the power coming out of the hot end. That I can't really confirm unless actually, if I just open the Stealthburner, I should be able to tell that. Here, what am I doing? I'm making you guys dizzy by having that camera so flipping close. There we go. Let's have a quick peek inside. Because I probably don't want to be plugging in. Where are my wrenches? The heck are my wrenches? Oh, right here, right in front of me. I probably don't want to be plugging in my 5-volt power supply into the 3.3 volt signal supply. Anyways, let's pop this open. Okay. And let's have a peek right here. Okay, so that's, what the heck? So there is my LED wires coming out right here. But what have I done here? I've got, how is that possible? Unless I spliced that. I have a black and a white coming out here, and it's the chamber thermistor wires, which I've used, but I have a black and a white coming out there, but I have 2 blacks coming out here. So where the heck did I switch that up for my chamber thermistor? Unless, okay, I need to do a little bit of investigating here. Maybe I've been trying to, it's not that one. Maybe I'm trying to connect the wrong wires. But anyways, I'm going to pop this out so I can get access to my wires in here. Here's this guy down here. Oh, because it's coming from, just hang on a second here. I'm probably very confused here. That's still part of my large bundle here, and it ends up going in to the bundle right here. I don't think so, though. Because this chamber thermistor plug here, where are you? You're plugged in right here. Don't need you plugged in there. Okay. Okay, no wonder. Okay. I feel kind of silly. Hey, Ricky B. Multimeter time. Yeah, no. There's my chamber thermistor wire that was just sort of sitting doing nothing. So, and it was plugged into here, but I don't have a chamber thermistor. So now I need to find out where these two LED wires, which are running through my whole bundle, I need to find out where they're coming out. And they're coming down, they're coming and joining the bundle here. Or hang on a minute here, coming out here, coming through here, down through here, and that came out through here. Okay. I don't want to have to unclip wires here. I've ill prepared myself for this. That's all my bed stuff right here. So this is just the bed. Okay, this whole wire bundle that goes to the hot end runs down here. It comes down here through here. Is this the chamber thermistor wire right here? I think it is. Let's just see where this is going. Or no, this is the LED wire. It's coming down here. No, that's the LED strip. Okay, that's the LED strip. That's my LED strips on the top. Those are working fine. Okie doke. So those can stay where they are. Multimeter time. Yeah, oh yeah. I just need to find the other end. I just need to find the other end of this wire. Because that was a separate wire, if I'm not mistaken. It was not part of this big bundle here. And it's coming through here, all the way through here, and underneath. Let me just actually, easier if I just go ahead and, let's see. Let's just, a little bit of investigating, whatever. I don't want to be the guy that cut his wire inadvertently. Okay, I'll take that zip tie off. Let's figure out what's going on here. So there's that bundle that's coming in here. I'm pretty sure that other wire was a separate entity. There's my XY end stop. These are all coming to this breakout board. This one, okay, that's my LED strips. That 2 pins is split. One wire is the LED data, the other for filament sensor used in the ERCF. Well, okay. I see where you're saying, but it wasn't part of that overall bundle. I'm trying just to figure out where it goes to. Let me see. Continuity check for finding wires. Yeah, if I could find the other, if I could find the other end of that wire. So this one here, that's my LED strip. It helps if I have light under here, then I can see things a little better, a little easier. Move that power supply down a little bit there. I can see through here now. There we go. There we go. That one, that one. Oh, there it is right there. Huh. Okay, I found it. So what I had done, knowing I've just been doing too much. There we go. There they are right there. So what I did was I left them loose and tied them up in here, knowing that I was going to have to plug these in separate as the LED plugs. And I forgot I did that. So these are the two ends that I've been looking for right here. Yeah, yeah. So those are the ends they need here. So we're going to have red is 5 volt, white is signal. There they are. I had bundled them up, tied them up, and said, I'll get to them later. Look at that. See, always a solution, always an answer. Let's move that power supply back up there a little bit. We can put this wire back in place. This is the LED strips. So I'm not crazy. Well, I am, because I forget stuff. I'm sorry, I've been building so much, and it slipped my mind that I did that. I totally forgot that I did that. Okay, now, what are the chances that I can get a zip tie back into that slot? Let's have a look and see if I can get a zip tie back in there. Well, that just proves I'm human and I forget things. I was thinking, where are those two wires coming out? And so I thought it was this chamber thermistor wire, which it wasn't. This doesn't even need to be plugged in because there's no chamber thermistor hooked up here. I could plug it in because the chamber thermistor goes from up here down here, but I do believe now that, yeah, I need to use a CT plug-in here for the red plug of the NeoPixels. So let's see if I can't feed a zip tie. I cannot see that. Let's see if I can feed a zip tie through here. Again, it was easier without a bunch of wiring in the way. Okay. Come on. This is difficult. This is difficult. Five volt will be the 14-pin wire if you apply 5 volt to proper side of CT on breakout board. Okay. Well, we have, there's, oh, and it says it right there. I have to get my magnifier on, but yeah, one of these is 5 volt up here. And I'm trying to think of which side it is, but these are really well labeled. This breakout board is really well labeled. But I gotta, my struggle right now is, can I get this zip tie back in this one spot? Or is it really that critical? Although I'm anal, I like to have these wires all snuggled up a bit. That I see the slot I got to put it in, but the motor wire is in my way. Come on, come on, get in the hole. Get in the hole. There we go. Come on, feet up. Ah. Get in there. Okay. Okay. Tweezers. Where are my tweezers? I feel like I'm playing a game of Twister here. There we go. Oh. I got it. Yeah. Popped out the other side. There we go. Now, can I? Ay, ay, ay. Oh, that's the wrong one. I wanted this one. Ah. I wanted in this one. I was struggling to get it in this one. I wanted in this one. Oh, what is wrong with me? The hole is your home. Oh, come on. Okay, one more hole. Get in one more hole. I just want to tie this bundle up. I don't need to. You know what? I'm worrying too much on one stream about these wires. I'll just leave these for now. Matter of fact, I'll just take a zip tie. This is something I can struggle with off camera, so not a big deal. I'm wasting enough of your time trying to find wires and figuring out wires that I forgot that I put aside to hook up later. So there. So we'll just bundle these in. We'll just kind of tie that back in. There we go. Snug that in back there. Good enough for now. Still looks pretty good. There we go. But what if they enjoy watching me struggle? Leo, I'm sure they do. I'm sure there's nothing more exciting than watching Tim struggle with his wires. There we go. Okay, so now what I need to do is I need to wire up these two ends with some connectors. And I believe, where are my connectors? It's not these that I want. Huh. Give me a sec. Give me a second. These are the ones I want. Right here. Hey, Richard, you finally made it. Ah, the struggle's been real, my friend. The struggle has been real. I'm human like the rest of you. Yes, I am, Ricky B. Okay, these are the ones I want, and I'm just going to hook these up to single pin. I don't even know if these are called JSTs. These already have little things on them. I wonder, actually, first of all, let me find out which one of these is the 5-volt. Here's some humor. I have to wear this so that I can actually see. So where's my flashlight again? My head's going to get in your way. So here we go. Geez, this is craziness that I have to get this close. LED. There's one that says LED, which I believe is going to be 5-volt. But CT, ground, chamber thermistor, ground, and then we have chamber fan, CF fan, and LED. And then we have 24 volt. I don't want 24 volt, although I have LED 24 volt. But I only want 5 volts for the LED. So I've got the CT plug and the fan and the ground plug, and I've got the CF fan, the C fan, and the LED. Okay. Whew. Oh, we printed, Richard. Yeah, we printed a test cube already. We did some we discovered we calculated our extrusion multiplier to be 0.95 based on the top surface of this guy. And then we printed a test cube. So, and the test cube determined that I have to run input shaper once more and confirm my input shaper settings. And I have to do a pressure advance setting once more just to confirm my pressure advance on this particular filament. I don't think the filament I did the initial one for was a very good one. So I may be able to get away with I can get away with just using these plugs. These things are already, I don't even have to do any crimping with these. So, because these already have the particular ends on them that I need. So, I know that my signal wire is the middle one. I'm just going to confirm that my signal wire is the middle one on this. So we are looking at jumper 37, and the middle one is PB0. So I want PB0 on the middle one on that for the LED. So I can go ahead and open this up, and that is a 3-pin plug. So I can take this guy, and the white is my signal wire, and I can plug this into the middle. There we go. So that's the signal. And this can, oh no, that's the different kind of plug. What am I doing? I need that for up there. Okay, so forget that. So I do need to, basically I need to cut that off just like that. Okay. And grab my snippers and my snippers and my twippers. White's my signal. So let's go ahead and strip that off. Or can I just use the 5 volts off that? I don't know. Apparently there's an issue with the 3.3 volt thing and all that. So who knows? Okay, let's cut that. Okay, we'll just grab one of these little doomer thingies here. Strippers. Yeah, you have strippers on the channel now. Woohoo! Yeah. Okay, this one we just come in. Make sure that we're not going to squeeze the actual plug portion. This takes a little bit of practice, this portion, but hey, I've gotten rather pretty good versed at this stuff. There we go. And then we insert. Look at that, no glasses either. And we crimp. And we check our work. And it's pretty good. Then we take our single pin. Actually, I'm going to do the 3. No, I'm going to do the single pin. And then we find out which way it goes. And I believe it goes this way. Come on, get in. There we go. Okay, and that goes to the middle pin on the red one. Oh, I can use all 3 pins from that connector to connect the LEDs. Okay. So then definitely I will. So the middle one, there we go. That's a signal. And then the ground, the 5 volt, and according to this, the 5 volt is, so if we're going this way, 5 volt is the one below it on the bottom. Okay. So we'll do the same with this pin then. So we'll snip this off, strip this guy a little bit more. Okay. On signal line. Okay. Grab another one of these little things. I don't even know what these are technically called. I call them little metal thingamajiggers. We'll load it in the crimper. Strippers. There we go. Get the wire in there. And crimp. And it looks good. Grab another. I suppose I could have used a double plug, but that's okay. This works too. And oh, wrong side. Goes in this side. Get in there. Are you a little bent? Are you a diver and you're a little bent? There we go. Okay, so now this will go in. Light again so I can see on the bottom of that one. Here, let's pull the signal out. Let's put the 5 volt on first. There we go. And then let's put the signal wire on. Come on. Okay, there we go. Okay, let's see if that works. Let's see if that gives us, whoops, let's see if that gives us some LEDs. Because I want to see, I got the rainbow barf in there. I really want to see the rainbow barf do its thing. But I don't have the, I don't think I have the config file set up for that. So, okay, so let's see if we get smoke, guys. I didn't unplug the chamber fan though. Let me just make sure that I didn't, no, I didn't do anything silly. That's going to that one, which is going to that one. No, that's good. No, I didn't. It was a chamber thermistor I unplugged. Okay, so we're not even going to turn this up on its end yet. We're just going to go like this, start it up, watch it boot here. There we go. We'll see if we get some LEDs, man. Okay. See if we get our screen here. I know it's sideways, but hey. And there we go. Okay, we're booted. We is booted. Okay, let's go ahead and load it up here and let's go see if these turn on. So let's go set nozzle LEDs on. Come on, please work. Please work. It's not working. No, we have no LEDs coming on. Okay, so that could be why. See, so there's no LEDs coming on, but I recall plugging the 5 volt power in somewhere else. Now, It's a possible. Just lick your fingers and go for it. Bare metal strip on the back is live. Oh, you mean here? Yeah, I'm trying to be careful everywhere. I have not shocked myself yet, but that doesn't mean that it can't happen. Oh. Neil. I didn't plug it back in on the head. Let's power it down. Oh, I should have powered it down there first. Okay, my bad. I do that a lot. I didn't plug it back in here. Oh, you know, sometimes I look at myself and I shake my head and go, Tim. Not that that's the issue, but I'm sure that it really helps if both ends of the wire are plugged in. Just guessing that it might work better if it's plugged in the other end too. Okay, let's start it up again. Oh, it is hot pluggable? I never know what's hot pluggable and what's not. Yeah, I didn't plug it in. No, I didn't plug it into a fan header and switch to 5. I plugged it into the LED header, or the LED header, and it's supposed to. We'll see what happens. And then if it doesn't work, then I've got to plug it into a 5-volt header. Okay, let's see if we are in fact rebooted, and we are rebooted. Let's go ahead and turn on nozzle LEDs. And nothing. Okay, so I think it's definitely that I have to plug that 5-volt source into something else. Okay, so let's power this off again. Okay. I shouldn't have done that again. I keep forgetting to go to Clipper and shut down. So what we need to do is get this 5-volt header. We need to give this 5 volts from somewhere else, and I think we're going to find a fan header and switch it to 5 volts. And I'm trying to see which one I can use. I can use this one right here. Right here. I don't know if there's 5-volt on the PCB here. We have the chamber thermistor, and then we have the ground, and then we have a chamber fan and LED. Now, is the chamber thermistor plug on here? Is that 5 volts coming out of that? I wouldn't imagine if it's a thermistor you're having 5 volts coming out, or are you? I did go to HARC 123 repo, but I couldn't find anything about it. I couldn't find anything about it. Let me go again. Let me have a look again. But it wouldn't work. I could not get the power. I could not get it to power off the 5-volt on the LED plug here on the 2.4 either. I had to take the 5 volts and run the 5 volts, I believe, as Zenbender said, off of a fan port with a jumper switch to 5 volts. I believe, but I could be wrong. Most thermistors are 3.3. Yeah. Okay, let me look. Let me just see if I can find repo. Okay, let me just see. Bear with me 1 second. Stealthburner toolhead PCB. Okay. And let's have a look and see if I can find it here. I've looked here and I could not find it. Wiring and octopus wiring. Okay, let's have a look here. Oh, you know what? That's the okay, sorry, I'm not seeing chat if anybody's 2-pin connector on toolhead is for signal and ERCF. Should work from that port. Yeah, and it's an octopus, Jeremy. Yeah, it is. Okay, let me just see. Is that not the Stealthburner toolhead PCB? That's not the 2-piece though. Let's just see in the Voron hardware. I'm on his GitHub right now, and I'm just looking for the specifically for the 2-part PCB here. Bear with me 1 second. Stealthburner PCB. No. Stealthburner toolhead PCB, but it doesn't. It's not showing the 2-part. Okay. Okay, let me look at one thing here. Bear with me 1 second, guys. I know you're probably chatting, but I'm not seeing the chat window. No, and I've seen this drawing before. Anyways, hey, Steve. Stealthburner PCB near the bottom. Okay, well, let me go back and scroll down near the bottom. Stealthburner PCB. Let's see. Okay. Okay, there we are. Stealthburner 2-piece PCB. Scrolling down, LDO breakout CT. Okay. That's the one right there. Okay, so it goes in the plug where it says LDO breakout CT. Okay, and then the LED signal. Okay, that's exactly where I need to plug it in. Okay. Okay, so it's that plug there. So I knew it had something to do with the chamber thermistor as well. So right here's what I'm seeing here. Let me move this over here. Okay. Here's what I'm seeing where this 5-volt is going to plug in right there. Okay, because then we have the signal, which I've got. I've got the LED signal coming in here. Okay. I don't have a filament sensor, so I'm not worried about that. But there's where the 5-volt for the LED comes in right here, the LDO breakout CT. So that's where the chamber thermistor would normally plug in. And I'm pretty sure, if I recall on the 2.4, that is where I plugged in the 5-volt on the LED was right there. So that makes sense. That kind of makes sense to me now. And that's the bottom one, and it's the one closest to the inside of the board. And it's right next to the, yeah, okay. That makes sense to me. Okay. So we're going to try it. Yeah. So according to that, this needs to go in right there. So what have I got to lose besides my sanity? You think I plugged the ECRF? No, that's definitely the LED power that we plugged in there. Let's see. It's already pinned out to be 5 volts, I believe. Let me just have a look here. Or is it? Yes. Well, we're going to find out in a second here. Let's just find out. Let's go ahead, make sure we're started. We are started. There we are. Let's see. And nothing. Okay, well, that wasn't it. Okay. No whammy, no whammy, no whammy. Oh, you see when I plug, you mean when I plug this in, my fingers are very close? Yeah, I know. You're speaking really close to this little guy in here. Yeah, I know, yeah. Did I get the proper CT connector? Well, I'm sure this is right. I do have a chamber thermistor wire, but you know, why do I think this is done differently than cool? Yes, the 2 wires are going to the tool head, to the 2-pin. The 2 wires are going in here to the 2-pin connector right there, which is the LED, which is the LED plug. So the 2 wires are going in there now. That's not to say, well, I was going to say it's not to say I didn't wire something up wrong in the head. What I need to test is I need to make sure, number one, I'm going to grab my meter out. Which somebody's going to say, yeah, you should have done this to begin with. I'm going to make sure I'm getting the right voltage out of that pin. Then I can ground that to anywhere that can get grounded. So I want to make sure I'm getting the right voltage out of that pin. Because I think the issue here is just getting the power. Okay. Come on, wires, untangle. So the 5 volts need to go to the LDO breakout chamber thermistor pin. Yes. So you're saying, oh, to the chamber thermistor breakout pin here is where the 5 volt plug should be going. Okay, and I know you said that earlier. So what you're basically saying is that it needs to go right up in here. which is we have the ground and we have the CT pin right here. So if I plug the 5-volt into the CT pin, okay, let me make sure, number one, that let me check the voltage on that pin, just because I can. I got the meter out, I may as well use it. And I'm going to move my hand out of here when I'm plugging this in just to make you more comfortable. There we go. So let me check the voltage coming out of that pin to make sure we're going to get 5 volts out of that pin. I am on the AC voltage. Or is that DC voltage now? I always get that confused. AC. Okay, so very carefully, oops. Duh. Yeah, this is for Toolhead NeoPixels. Randy, you got it. Now, I'm not showing anything coming out of that, but it doesn't mean I don't know if my grounding pin is, don't know if I'm hitting the ground pin or not on here. I guess I could ground this to my ground here. Yeah, so that's showing, I'm getting 7.25 volts out of that chamber thermistor pin, which is probably fine. Yeah, showing 7.25 volts here. I'll turn this so you guys can kind of see the screen. This is the chamber thermistor pin I'm touching right there. 7.25 volts. So, okay, let's try that. We can hot plug this. Okay, we've got that. We've got that. Let's see if anything turns on here. And nothing. Now, the only other thing I can think of, so we're not getting any LEDs at all to the hot end now, even though we do have voltage coming out of it. Now, the only other thing I can think of, the only other thing I can think of here, let me just check one more voltage reading here, is that I've got something, either I've got the wires crossed plugging into the hot end, or I'm just having an issue with the wires going from the breakout board on the hot end on that 2-part board, and I'm not getting a proper connection up at that end. So let me just see, make sure that this one where they recommended it goes. See, I'm getting, unless my meter is off, that can't be right. And then let's pop this one off. Let's just see the voltage coming out of this should be 5 volts coming out of the LED plug here. See, everywhere I'm supposed to be. Okay, I don't know what, so theoretically, okay, I'm on, no, I was on AC setting. Should I be on DC setting? Okay, DC. Okay, maybe I'm on the wrong setting. Hang on a second here, guys. Maybe I'm on the wrong setting. Hang on. Let's see, right here. No. No, I'm not getting anything out of that. DC. Yeah, I should be on DC. Unless my meter is screwed. Oh, hang on a second here. DC. Hang on a second here. New meter. Let's see if this makes a difference. Mm-hmm. Oh, come on. They go direct into the LED header. 3 leads. No, there's only 2 leads. Now I'm using a Stealthburner PCB. It only has 2 leads. It shares a ground. My meter is going freaking wonky here for some reason. Let's turn this off. We need this to be into the DC 10 amp side. Turn this on to DC voltage. I wonder if my battery's low in this meter or something. Let me switch meters. Give me a sec. Let me switch to a different meter here. Okay. Let me switch. I'm new to all this stuff, guys. So yeah, some of you out there going, what an idiot, but hey, this is how I learn. Hopefully this meter has power. Do I have a little stand on this? I don't. Okay, DC voltage. Boom. Oh, and look at that. I even have DC voltage setting on this. There we go. These are a little finer points too.
DC minus 101.0 millivolt.
Okay. This one talks to me too. Put them together, I get 0 volts. Okay, we are good. Let's see what we can get here. You can do a lot of damage. Yeah, I know if you don't use it properly, and that's...
DC 186.7 millivolt.
Let's try something else here.
DC minus 166.1 millivolt.
These meters are just... Oh, good point. Let's see. Yeah, that's an earth ground. Where's my DC ground? It's going to be my blue, isn't it? The blues are going to be my ground. My red is my hot. It's all the meter's fault. No. Okay, I need to hang on a second here. Okay, you guys are waiting for sparks, I know. Use V on the PSU. Okay. Volt minus on the PSU. Here we go. There we go. Well, let's just test this and make sure we're getting an accurate reading on the meter anyways. Okay, there we go. I'm on DC voltage on my meter, and I'm getting a really weird freaking reading from it. What's going on? I'm on DC side. Line, neutral, earth. Oh, I see. Okay, use the DC negative and okay. And the power into the board under the red plat. Okay, in the board. Where's my negative? There's my negative right here. Let's take this cover off. Flip it up. No, I can't get it. Come on. There we are. Still getting weird readings. Okay. Okay, number one, I don't want millivolts. Let's see, volts. There we go. Let's switch this to volts. Negative here, on here. Doesn't look like we're getting any voltage out of that. Let's try the LED port. Why are you... The heck? This is weird, weird, weird. Test my PSU voltage. We'll get sparks yet, don't worry. Okay, we have 24.14 volts coming out of the power supply. 24.14. So here, let me just... There's our power supply voltage right there. So we're pretty good. Okay, so that's okay. I don't think I need to dial that down a little. So now if I go negative here, and if I... Okay, we have 5 volts coming out of here for sure. There we go. Now we seem to be getting somewhere. So right here.
DC 4.96 volt.
Okay, that's good. And up there, we're not getting anything out of that. So we're getting our 5 volts out of the LED. So we should be able to, as somebody said earlier, we should be able to plug them both in right here. Because we're getting 5 volts out of here.
DC 4.96 volt.
Okay, so we should be able to put our signal in here and our power in there for the LED. Should be able to. And we got consistent voltage out of that. Now, I'm just curious where they say to plug it in here. I just want to measure the voltage coming out of this one where they say to plug it in based on that guide, which was right in here. Okay, and that's at 24. That was not set for 5 volt.
DC 2 4.15 volt.
There we go. Okay. Possible I blew the LEDs. It's possible. Okay, let's power that off. If I ran 24 volts into them, hey, I might have just given myself more work to do. So I should be able to power this. Now, again, it's possible that there's an issue with the wiring between the breakout board on the hot end and the LED wires. So that should be able to go in right there for signal and power out of that one port. You need to run 5 volt to the LDO board in CT port. You will not get power out of LDO board. Power can only come out of Octopus to it. Okay, but okay. The 2-pin wire should not be connected to 5 volts. I'm just, and I appreciate all the feedback. I'm just getting a little confused on the feedback right now. So let me, what I really should do is I really should open up my 2.4 and see exactly how I wired the LEDs on it, because it's going to be the same, because it's the same hot end, it's the same breakout board, it's the same 2-part PCB, and it's the same 2 wires coming down off of that board. Neither one of these is 5 volts. So where are the LEDs getting their power from if neither one is 5 volts? The LEDs have to be powered from something. Okay, there's a link. Let me look at this link. Oh, what's going on here? Yeah, I did, Zen. So from the Octopus to the LDO CT port and the tool head. Okay. So, I see what you're saying, Delmar. Okay. I kind of see what you're saying now. I struggled with this on the 2.4 as well, if I recall. And I think I just need to, a light bulb needs to click in order for me to get this right. Okay. Hey, 3D Medic Vince. Okay, so what you're saying is that the chamber thermistor port on the breakout board is what's supplying the 5 volts from the, okay, comes from the Octopus board through the chamber thermistor on the breakout. Okay. That makes sense. So I need to put this back in. Okay. Okay. I think I'm kind of starting to get it now. I think I'm getting it now. So this has got to go back in here, chamber thermistor. And then this guy, I want to make sure I get this in the right port. Yeah. Maybe I've been doing this wrong the whole time, and everybody's going to say, I told you so. Let me look on the, I'm just going to look on here, and I want to see where I'm supposed to plug in the chamber thermistor. On the LED strip. I'm not worried about the strip. The strip is working fine. Chamber thermistor plugs in right there. So let's go ahead and open a high resolution image of that. How do I get this bigger? There we go. Chamber thermistor plugs in. It's the third one down. Okay, and that is the Why can't I use LDO docks for this? If it's supposed, oh man. Oh, yeah, chamber thermistor was plugged in right here. But if that's providing the 5 volts to the LEDs, what difference does it make? They're expecting me to use their AB board. Okay. Okie dokie. Okay, let me look at the HARC. Delmar keeps saying go to the HARC 123 repo, and let me look at that HARC repo again. And I believe it was, where did I find that? Let me go back to the HARC LDO repo. We're gonna shut her down here. We're at my 8 o'clock, and I'm getting, I think I'm hungry and tired. Oops. I'll get this figured out eventually. I have no doubt about that. Okay, we're at the repo. Oh man, I've got this screen zoomed in, that's why. The control minus. Okay, let's see what he says here. Okay, let's go down to where I found okay. Oh, come on. Come on. Yeah, I have the right pin set. I have the, well, we're just trying to get the power to the LED. I have the right signal pin set. It's PB0. Would have been easier if I just opened my 2.4 an hour ago and copied what I did on the 2.4. I'm just trying to find where to find in the HART 1213 repository. I'm trying to find. There we go. Voron SBPCB, Stealthburner PCB, Voron 2, Stealthburner PCB, Afterburner toolhead, no, Stealthburner toolhead PCB, updated photos. Let's go down and NeoPixel data pin. Okay, here we go. Okay, so I see what you guys have been saying. Okay, I really do. Okay, going down. Let's go down to the picture of the main board and this one. Okay, so we have 5 volt. It's coming out of there. Okay. Stealthburner board will work with the LDO wiring harness. Okay. It's on the 5 volt setting, and the CT wire is going to the positive pin of that header. Okay. LDO breakout CT. And then we move. Okay. Okay, I see what it's saying here. Okay, I think this is where I've gone way, way left field. Oh, you can't see. Oh, I'm sorry. Sorry, guys. Sorry about that. Here, let me do this. Okay, so what it's saying here is, yeah, so we're getting the 5 volts from the CT plug, chamber thermistor plug right here, which is what I've got the one end plugged into. Then it looks like here that I basically have to, can I zoom that in at all? Let's see, let me zoom that in. Why am I zooming at? Oh, zoom in the other way. So what I'm gathering here is that I need to move this pin over to here to make it 5 volts, and then the other end of the CT plug goes in here, which is going to put the power up to the chamber thermistor plug on the breakout board. Okay, that's what I'm gathering. Okay, and Delmar says yes. Yeah. Okay, so I've got to move the pin over to the 5 volt position, plug the other end of the chamber thermistor in here, and that should give me the 5 volt power to the LED, and then I just plug the signal wire into the middle pin of the LED signal in PB0. Oh, okay. Only the one wire of the plug. Okay, so just the one wire of the plug. Okay, so all I'm doing is using the one wire, that one. Okay, so I can snip. And that is the, let's just see, up here. So that's chamber thermistor. Man, I cannot see for the life of me. Chamber thermistor and ground. Okay, fair enough. So the CT wire is going to be the white wire. Okay, actually, I'm going to power off for this. Let me shut her down for this so I don't electrocute myself or do something silly when I pull that pin. Maybe I don't have to, but I'm going to feel more comfortable powering it down. Okay. Okay. So my tweezers. So what they're saying is to take this last one. We're going to take the jumper. Come on, jumper. I hate pulling these jumpers off. I just find them difficult to get off sometimes, but I'll get it. Okay, there we go. So we take that jumper, put it on the third one, okay, which should give us 5 volts in that one. Okay, so we got the jumper there. Okie doke. Now, then we take this one, and we only want on the inside, so we only want the 5 volts. So am I to snip the other wire? Remove the black wire. Okay. So I can just snip the wire. I don't really need to take it off of there as long as I'm not getting the signal. So, and I got lots of wire here. So I can just go snip. We've removed the black wire altogether. Then we're going to plug this in like so. And then I really only need, if one of these is for filament sensor, I really only need the white one for the signal to the middle plug. That should be it. There's a hole between two, but you can stick tweezers in and pull the jumper out. Don't snip, just pull the crimp. Okay, I got it out anyways, yeah. Okay, so this should be good. Let's hope this is good. I knew I'd eventually get there. I'm just slow sometimes. Slow to the draw sometimes. Okay. Okay, let's power it up and see what happens. And if they don't come on this time, I've either blown them or, no, I couldn't have blown them because I just didn't have any power going to them. Yeah, no, I had actually, because I was plugging the wrong wires in, I was sending power to nowhere. If they don't work this time, then it just means that I could have a wiring issue up in the hot end. As I say, I'm slow, but I get there eventually. And we are powered on. We have life. Let's go ahead and see if they work. Now, nothing coming on, but the one thing, or I swap the red and white leads. That's a possibility too. That's a possibility too. So before I give up, because they're not coming on, let me switch the red and the white and see if maybe I switch the red and the white leads, and the red is actually the signal wire. And it's not going to harm anything because I don't have a filament sensor, but let's just see. You never know. So the signal's on. Let's just see. Nope. Because I tried the other black wire. Now also, there we go. I could also possibly have the config file screwed up, because basically I know that it's reading the config file because it's giving me all these options for the LEDs. And every time I click one of those, the light should come on and change to whatever color. Nozzle LEDs should come on, but it doesn't mean I haven't effed up my, where are they? So yes, just so you know, I have a NeoPixel config file, and in my printer config, I have pointed to I have included the NeoPixel config file. So, and the NeoPixel config file is pretty standard. I've got the PB0 for the signal wire. So PB0, chain count 3, green, red, blue, white. This is copied basically over from my 2.4 because it's basically, I wonder, see, at least the nozzle LED should come on. So I think I need to check the wiring. Yeah, I'm not sure if they'll come on if the config is wrong. You swear you saw something crawl across the camera lens. It's possible. Who knows? The way my night's been going, you never know. But it's a tiny, tiny lens. Maybe something did. The lens is only like this big. So it wouldn't. Oh, I wouldn't put it by myself that if I have a wiring issue up in the hot end. I had a hell of a time getting the. They should default to all white at 50% output. Okay, I had a hell of a time getting the Rainbow Barf NeoPixel in. So I might have damaged a wire. I don't know. But I think at this point, I've got everything hooked up correctly. Now that we've finally cleared my thick skull and I figured out the whole 5-volt thing and the signal thing. Because the config file looks fine. I don't see anything wrong with the config file. Yeah. I don't have the rainbow barf config file, which I need to get, and I need to configure my rainbow barf, but something should be coming on anyways. You have the LDO AB afterburner Stealthburner boards on your LEDs, go right to the big tree tech board. Well, see, I've got the 2-part PCB on the hot end on the Stealthburner. Do you have the 2-part Stealthburner PCB? Nine pixels, not 3. That could be now this one, yeah. So this would be okay. Let's change that because we do know that that's 9. Now let's see what's going on. I'm going to have to. We'll come back to this, but nothing's working. Not even the nozzle LED should be coming on anyways. But there's nothing coming on at all. Anyways. Okay. Yeah, it's the Hark board 2-piece. Put the cover and check the voltage. Yeah, see if I'm getting any voltage up to it. It's a good point. Let's do that real quick. I gotta get some supper. No, I'm not going to be able to pull the cover and check the voltage. Yeah, I can on the pins. I got to take this apart anyways and double check the everything, because what's going to happen here is with the 2-part PCB, nozzle LEDs would be number 8 and number 9. Okay, let's have a look. Oh, it was some dust. Looked like something was crawling across. Ugh. An uninvited guest. Because what will happen here is this is going to, that's off. That's off. These are off. And there we are. Yeah, because that's going to unplug. Of course, I got my LEDs in here. The wiring in here all looks fine, so I'm not overly concerned. There's my LED wires right here, my 3. Now, checking the voltage on these pins, numbers on these. Oh, man. So some are fans and some are LEDs. Now, let me see if I can find that image of that board. Bear with me 1 second here. Where did I put it? No, that's not where it was. Okay. I'm just checking real quick here. So I'll check something really quick here. Okay. Okay, so the other end, where's the other end of that board? Okay. You like the two-piece board. So this comes off, boom, and we just plug in here. I just want to find out. Oh, here we go. Man, that's so tiny. That's type on these things is so tiny. LED is the third one in, so the LED is going to be this one. I'm just not sure. And 5 volt is the, so we should be getting 5 volt. Okay, so we should be getting 5 volt out of the top one. That's LED 5 volt, 24 volt for the fan. Let's have a look and see if we're getting voltage out of there. Okay, ground. Where am I going to ground for this? Where can I ground for this? I guess I can ground right off of the damn YouTube notifications. I don't think I can ground off the bottom. Yeah, I should be able to. No. DC. Where's my ground back here? I know for sure I can ground back here. Okay. Let's just see what we get here. Make sure we're working. Hang on. Let's check the fan. Now I just blew something. Yeah, I just blew something. Oh, man. I shouldn't be doing this when I'm tired. Oh, we restarted. That's why. Let's do this again. I saw a spark. I sparked. Mm-hmm. Okay, we're okay. I just caused my system to reset. I've got to be careful where I'm touching what. Okay.
DC 19.51 volt. DC 24.13 volt.
Okay, that's the fan. I just got to be careful here. It's really...
DC 6.0 millivolt.
Come on. Yeah, it doesn't look like I'm getting... No. I got to do this a little different. I'm having a hard time getting the probe to touch just one of those pins. Yeah, I'm having, it's my shaky hands. Yeah, yeah, exactly. So I don't have to hold the ground. We're going to continue this. It's getting, I'm over half hour overdue. Just want to make sure we start up and I haven't really damaged anything permanently. Let's just make sure. You saw a spark. No smoke, just a spark, Richard. As long as we start up okay and my LEDs turn on here, which they will. There we go. Yeah, we're okay. Okay, well, I need to configure this a little different. Yeah, I need to be able to, so we know we're getting good voltage out of the fan, so we know it's all working. We know we're getting power up here, but I'm just having a hard time holding my meter on here. And you're right, I need a better way to hold the ground so I'm not reaching around. Smoke came out the bottom. Where? But where? I don't smell anything. Everything's working. Here, let me make sure. Let me plug this back in. Let me make sure everything's still working. I can home it on its side. I'll have to watch it back and look for smoke. Okay, we're working. So far. Let me double check. Let me make sure that let me make sure we can heat it up. Let's go ahead. Okay. Fans coming on. Okay, we're heating up. No problems. Okay. Let's make sure the bed heats up. All the fans are working. Beds are heating. Okay, so the bed's heating. We're good. Getting reading off the pipe. Yeah, I think we're okay. You saw smoke. I'm going to have to watch that back and see. Cool. Smoke makes for more views. You know that. So. Okay, well, that's it. That's all. We're going to shut this down now. Let's just make sure my hot end cools down. Interesting. I don't know where. I don't smell. Nothing. So I don't smell anything, which is good. Nothing's burned. And everything seems to be functioning. Let's see if the fan kicks off at 50. And my hot end fan kicked off at 50. Yeah. No, there's no smell at all. Okay. Yeah, I'll use a connector. I'll do that next time. Maybe we will. Maybe next week I will. Let's just shut this down. Shut it down. There we go. Okay, now we're free from smoke. You know. It's been a stream. Why did you do that? Hang on a minute. What's going on here? No, that's not what I want to see. That's what I wanted to see. Okay. Anyways, guys, I know it was painful to watch. And yeah, there was maybe smoke. I'm going to have to watch back and make sure. I believe you guys that there was smoke. I want to watch back and see. And then that maybe be the thumbnail for my next week's stream. But I'll play with this a little bit during the week too. But we'll figure it out. So there's obviously something going on between, I need to find out if there's voltage getting to the LEDs on the hot end. I didn't screw this back in, so I got to check my wiring in here. Oh, thanks, Jack. I don't know if I'd call it awesome. I'd call it interesting. It took a little bit of pounding into my head from everybody to make me realize how these LEDs should be hooked up, because I was thinking a little bit wrong there for a bit. But I'm going to check my wiring in here. I got to make sure I didn't damage any wires when I pushed the rainbow barf. I had a hard time getting the rainbow barf in here. The only way that's going to come out for me to check is I'm going to have to reprint this this part here, because that is in there so tight that I'm probably going to have to crack this open in order to get it out. I remember when I put it in, it was an extremely tight fit. So it's very possible that I have broken or crossed or screwed up the wiring going into the rainbow barf LED. And if that's the case, because they're all connected, that could be the reason the LEDs aren't turning on. Oh, okay. If I touch the 5-volt and ground that pin connector, it could have been the 5-volt step down and the octopus is just blowing. Okay, well, we'll have to test that and see if we're still getting the 5 volts out. So we can definitely test that. But yeah, that was a bit awkward with, yeah, anyways. And I have the tips of these aren't the best for going into those little pins, because if you're shaky at all, it's not hard to slip down. And I think that's exactly what happened, is I hit the 5-volt and the ground at the same time. So, but anyways, nothing that can't be fixed. So, okay, I'll call you tomorrow, Richard. And for the rest of you guys, thank you everybody for hanging out. I appreciate everybody's patience and help and everything tonight. So, thanks for watching. We'll catch all you guys next week, and we'll get this figured out one way or the other. Okay, talk to you guys later. Have a great night. Bye for now.